Hello everyone, so it's finally time for me to do binomial distribution. So let's get right into this. So first things first, how to tell if this is a binomial question? Well, very good question you ask. So I have divided that into three criteria. So first being that for it to be a binomial distribution, the probability of success must stay the same. So let's say that you are playing a game with your friends and the probability of you winning is 0.9, right? Now say that you play that game for 5 times. So if the probability of you winning the game for the number of times you play the game stays the same, so for first game your probability of winning is 0.9, second game is also 0.9, third game is 0.9, so on and so forth, then it's a binomial distribution question. Now say that your probability of winning keeps changing, so first game you have a probability of 0.9 and now you have a probability of 0.5, meaning that this is not a binomial distribution question. So that's one example. Now say that the probability of it raining today is going to be 0.5 and the probability that it rains tomorrow, if it rains today, is going to be 0.9. So you can clearly see that probability that it rains tomorrow depends on the probability that it rains today, right? So in that case, this is not a binomial distribution question. So I hope that made sense. So basically what I'm trying to say is that each trial is independent of each other. So the first time you play the game is independent of the second time you play the game, and so on and so forth. Alright, the next criteria is there is either a success or a failure. There is nothing in between. So this is kind of like discrete probability where you either win or you lose. Nothing in between. And the third that I haven't written down here, come on man, you can figure it out. You just need to practice, right? Without practice, you can't do much. So keep practicing these sort of questions, these probability questions, and then you can easily differentiate between which concept to apply in which question. Okay, so notations. So in binomial distribution, n is the number of trials and p is the probability of success. Alright, and define a random variable x. Okay, I'll expand more on this as I do the question. I'll explain what I mean. So now let's look at the formulas. So the formulas, this is the main formula to calculate probability in binomial distribution, and this component over here also has its own formula which involves taking factorials of numbers. I'll go over it in a bit. So basically what does this formula convey? What does this mean? It just means number of ways to get k amount of successes in n number of trials. So that's what this formula gives us information about. Well, let me explain these things thoroughly as I do this question 1. So a biased coin has a probability of 0.75 to toss a head and 0.25 to toss a tail. The coin was tossed 5 times and each trial is independent of others. Now because each trial is independent of others, it's going to be quite clear that it's going to be a binomial distribution question. Find the probability that exactly 3 heads were tossed. Now, first things first, I'm going to expand on this thing now. So define a random variable. Now, what do I mean by random variable? So we assign a variable in this question to represent something. So for example, in this question we can say that let x be the number of heads tossed. Why is this important, you ask? Well, if I'm marking your exam paper and if I don't see this, I don't even know what x represents. X can represent the amount of chickens walking on the road for all I care. So for the questions that does not have a random variable defined already, please define your own random variable and make a wise choice. So here we are asked to have 3 heads tossed, so that's why I said let x be the number of heads tossed. If this was tails question, I would have said let x be the number of times tails was tossed, and so on and so forth. Now one more thing I need to mention is that whenever there is a binomial question, there is a special syntax that we use, which is x, this weird symbol, and binomial, n and p, where n is the number of trials and p is the probability of success, as I already written over here. Now these two things are a must to write in the exam. It gives you and also the exam marker a clear idea of where you are going and x represents what. If not, the examiner is going to get confused, and sometimes even you can get confused if there is multiple things going around in the question, which is quite usual thing in probability questions. Okay, let me define the syntax correctly. So x is binomial number of trials is going to be 5, and the probability of success is going to be 0.75. Okay, and sometimes just defining this correctly can potentially give you a mark in VCA exam. Sometimes, okay? So it's always best to define this thing when it is not already given in the question. Okay, let's calculate this. So what we are asked to do is to find the probability that exactly 3 heads were tossed. So probability of x equals to 3 is going to be, I'm just going to apply this formula over here, so that's going to be 3 times probability of success, which is 0.75 to the power of k, so 3 to the power of 3 times 0.25. 1 minus 0.75 is going to be 0.25 to the power of 5 minus 3, which is just going to be 2. Now let's calculate this portion over here. So 5 and 3, if you calculate this, it's going to be 5 factorial divided by 3 factorial times 5 minus 3 factorial. Now in exam 1, if this question were to come up in exam 1, they will surely give you a better number so that you don't have to apply this formula over here, because throughout the exam 1 practice I did when I was doing year 12, I don't remember of encountering a scenario where I have to use this formula. I just basically never did. So this question is just so that I can show you how to calculate this part on CAS. So I'll do that after I finish this part A. So this will simplify to 10 because I already did this in CAS. I'll show you how to do it, but just for information, what does this 5 factorial mean? So 5 factorial would be 5 times 4 times 3 times 2 times 1, and this is how you calculate 5 factorial. If it's 3 factorial, then that would be 3 times 2 times 1, so on and so forth. Okay, so now again I'm going to put this in the formula. So this would be 10 times 3 on 4 to the power of 3 times 1 on 4 to the power of 2. So this will be 10 times 27 over 64 times 1 on 16, and that would give you 135 on 512. Now again, the numbers, if this was to be an exam 1 question, would be a lot more simple, so you don't have to go through this formula over here, and I'll quickly show you how to evaluate this portion on CAS now. Alright, so what you do is press menu 5.3, now type in 5,3, press enter, and that's how you do it. Alright, so let's move on to part B. So find the probability that no heads were tossed. Express your answer in form of this, where A, B and C is going to be Z. Now Z is what? Integers, positive integers. Okay, so let's do that now. So we have to calculate probability that X is going to be 0, and that would mean that it's going to be 0 times 3 over 4 to the power of 0 times 1 minus 3 over 4 to the power of 5. Now this, if it's going to be n and 0, this is always going to be 1. So these are the sort of questions that you can expect in VCA exam 1, where they give you bottom number as 0, so number of successes that they want is 0, so it's just going to evaluate and become 1 times 1 times 1 on 4 to the power of 5. So answer is going to be 1 over 4 to the power of 5. Now I don't need to expand this because, well, they want the answer in this form over here, so we are good. Now one more thing that you might want to write in the exam just to be safe is that A is going to be 1, B is going to be 4, and C is going to be 5. Generally they don't assess this, but in case if they do, it's always better to write, and it's never wrong, so why not? I don't see a reason why not. Anyway, let's move on to question C. Okay, hence or otherwise. Okay, now what is the importance of this hence? Well, this wording is quite important because this hence is telling you to look up and see what you did, because you already done most of the work. And how exam is written, is that they will guide you step by step. They'll divide the question into different parts, into a particular amount of parts, and then they'll slowly ask you to calculate stuff to work on the final answer. So whenever you see a hence, the best thing I can tell you is look up, because most of the time you already done all the hard work, and hence is just going to put hard work into account and to get the final answer pretty easily. I'll show you what I mean. Or when you say hence or otherwise, meaning that you can use the parts that you have already done above, or you can also do the question starting from square one. Hence I use it quite a lot because, well, I just have to look up and I find the answer pretty easily. Okay, so hence or otherwise, find the probability that at least one head was tossed. Express your answer in this form where A, K, F and H is also positive integers. So probability that x is greater than or equals to 1 is what they want us to find, and this is exactly the same as 1 minus probability of x equals to 0. Do you remember something? Look up. What did we calculate? We have already calculated this, and that's why they wrote hence. That's why I wrote hence, because I made this question, so that's why I wrote hence. So all I have to do is just 1 minus 1 over 4 to the power of 5, and that's your answer. Literally, that's it. Now we should always make sure that we write it in the form that they want, and also specify a equals to 1, k equals to 1, f equals to 4, and h equals to 5. Again, I don't think that they check for this, but it's always better to be safe than sorry, so why not? Just write it, Okay. Question 2. A chocolate factory packs 150 boxes of chocolate every day, and each box contains 15 chocolates. It is also known that the machine may malfunction, leaving a 10% chance of chocolate being packed unwrapped. Okay. So 150 boxes every day, and one box contains 15 chocolates. Very good. So find the probability that there are exactly 4 chocolates that are unwrapped in a box. Now what's our first step? Define the random variable. So how do I define the random variable? So what are we looking for? Unwrapped chocolates in one box. So x is just going to be that. Let x be the number of chocolates unwrapped in a box. So this is our random variable defined. Now again, let's write the syntax. X binomial 15, and what's our chances of success? 0.1. Now probability that x is equals to 4. Again, now I'm just going to do this on CAS calculator because this is kind of like an exam 2 question. So I'm just going to do this on calculator and I'll show you how to do it. Now to solve this, what you do is press menu 55B, and number of trials is going to be 15. Probability of success is going to be 0.1. Lower bound is going to be 4, and upper bound is also going to be 4. Now you can ask, why didn't I pick Binomial PDF, where I can just type number of successes at 4 and then call it a day? The reason is that this tool does the exact same thing, and this tool is a bit more beneficial because it can also solve probability with different upper bound and lower bounds. So why not just remember one tool rather than remembering 2 tools which does the exact same thing, right? This one is a bit more powerful because it can do same upper bound and lower bound, and it can also do different upper bound and lower bound. So just utilize this one tool for 2 things. You can also make this as muscle memory too, rather than getting confused between PDF and CDF every single time. This would be a lot more easier and convenient. Now press enter, and there you go. That's how we do it. So our answer is going to be 0.0428. Now generally they ask the answer to 3 or 4 decimal places, so just look at the question to how many decimal places they want, and proceed from there. And find the probability that at least 3 chocolates are unwrapped in a box. Again, so they want us to find x is greater than or equals to 3. Now again, I'm going to do this on CAS and I'll show you. Press menu 55B again. Now number of trials doesn't change, so 15. Probability of success 0.1. Now this time the lower bound is going to be 3 and upper bound is going to be 15. And press enter, and there you go. As you can see, this tool did both things, same upper bound and lower bound, and also different upper bound and lower bound. So this tool is a lot more powerful than Binomial PDF, and that's why I prefer to use this, and I highly recommend you to do the same. So that is just going to be 0.1841, and there you go, that's your answer. Now, owner wanted to check the number of unwrapped chocolates produced in 1 week. So the factory was produced in 1 week. This is important to highlight. So the factory was kept running for 1 week and all the boxes were collected. If the box contained more than 4 unwrapped chocolates, that box was thrown away. Okay, so what does this mean? More than 4. So probability of x is more than 4. Isn't that the same as probability of x is greater than or equals to 5? Because there simply can't be 4.5 chocolates that are unwrapped in one box, right? So if it's greater than 4, it's going to be greater than or equals to 5. Same thing in binomial. Okay. Find the probability that at least 10 boxes were thrown away. Alrighty, so we know that there are 150 boxes produced in one day, right? So how many boxes would be produced in 1 week? 150 times 7, which is going to be 1050 boxes per week. And what we asked to find that at least 10 boxes were thrown away. Now what is the criteria that the box is being thrown away? Well, if there are more than 4 chocolates that are unwrapped in a box, then the box is thrown away. So we have to first find the probability that box is thrown away. One box is thrown away. How do I do that? Well, probability that a box is thrown away is going to be the same as probability that box contains more than 4 chocolates that are unwrapped, if that made sense. So first things we have to find is probability that x is greater than 4, which is going to be same as probability of x is greater than 5. So I'm going to write my syntax: x binom 15 and probability of it being damaged is 0.1, and probability of x is greater than or equals to 5 is going to, well, I'm going to again evaluate this on CAS, so I'm going to show it to you. Alright, so probability that x is greater than or equals to 5 is just going to be menu 5b, number of trials 15, probability of success 0.1, lower bound is 5, upper bound is 15, press enter, and there you go. So our evaluated answer is going to be 0.01272, and now we know the probability of one box being thrown away. So now we can look at the rest of the question, find the probability that at least 10 boxes were thrown away. Now, one more thing before we further proceed with question. So, can we use x as a random variable to represent boxes? No, we cannot. Why is that? Because, well, we already use x to represent the number of unwrapped chocolates in one box. So what does that mean? Well, we have to define a new random variable for the amount of boxes that are thrown away. So let me quickly do that. So let y be the number of boxes thrown away. So let me write the syntax: y binom. How many trials? The factory was running for a week. Well, how many boxes produced in a week? So 1050. And what's the probability that the box is being thrown away? What is the probability of success? It's going to be 0.01272. And what we are finding is probability of y is greater than 10. So let's evaluate this on CAS together. So now we have to find probability that y is greater than or equals to 10. Well, first we'll copy this probability over here, because look at the amount of decimal places. There you go. So CAS doesn't show every single decimal place. So that's why I recommend that you copy this. So Control A, Control C, and now you can go to menu 5b. Number of trials is going to be 1050 this time, because that's the number of boxes produced in 1 week. Probability of success, you can just paste that. Lower bound is going to be what? 10, because we have to find greater than or equals to 10. Upper bound is going to be 1050. Press OK, and there you go. That's how you do this. Alright, so when evaluated this on CAS, we'll get 0.8581 as our answer, and this is going to be your final answer. So read the question carefully and do not use the same random variable throughout if there's a twist in the question like this one. So suddenly the question went from unwrapped chocolates to number of boxes thrown away. So if you need to define a new random variable, do it. Do not be afraid. Alright, now let's move on to another part. So Wika's most favorite type of questions for binomial, so their hot favorite question, they involve finding least number of trials. I know these questions are quite painful if you don't understand how to do it, but don't worry, I'm going to be covering them, so you're going to be all fine. Alright, let's proceed with question 1. So Abdul was tossing an unbiased coin. Unbiased coin meaning that probability of tossing a head and tails is going to be the same, which is going to be 0.5. Find the minimum number of times he has to toss the coin so that the probability of him tossing a head at least once is more than 0.99. Okay, So how do we proceed? First step, define the random variable. I'm going to keep hammering this in your head, but this is such an important step. So let x be the number of heads tossed. What is our syntax? Do not forget to write the syntax as well. X binom n. We don't know the number of trials, so we just say n. And probability of success, it's an unbiased coin, so the probability of tossing a head is going to be 0.5, which is the same as the tails. And what we are meant to find is the value of n, number of trials, which fulfills that probability of x greater than 1 is going to be more than 0.99. So we know that probability that of x being greater than 1 is going to be equals to 1 minus probability of x is equals to 0. Correct? Alright, so that's going to be 1 minus probability of x is equals to 0, which is greater than 0.99, meaning that probability of x is equals to 0 is less than 0.01. All I did was I just moved this one to the other side and remove the negative sign, so of course the sign flips. Now we can just simply apply the binomial distribution formula, the probability of binomial distribution formula. So probability of x equals to 0 is going to be n 0 times probability of success is going to be 1 on 2 to the power of 0 times probability of failure, which is also 1 on 2 to the power of n minus 0, which is just going to be n, and that has to be less than 0.01. So this would just mean that 1 times 1 times 1 on 2 n has to be less than 0.01. So this is going to be half to the power of n is going to be less than 0.01. So that means n is going to be greater than log of base half, 0.01. Now, well, why did I change the sign? Good question. So let's say that you have to calculate log with any base, and the number is going to be between 0, less than x, less than 1. And this, if this is the condition, then this answer is always going to be negative. No matter what the base is, if the number is between 0 and 1, the log answer is going to be in negative. And that's why I flipped the sign, if that made sense. Okay, I hope that did. So now, if this was to be an exam 1 question, you most likely would just leave it like that in the exact form, because, well, you can't calculate this unless you're a super genius who can do logarithm in your head. But most of the time, they just expect you to leave it as an exact answer if this was an exam 1 question. And of course, we are not going to leave this like that. So let's evaluate this on CAS. This is going to be log of base 1 over 2, and it's going to be 0.01. And yeah, there you go. So we will get n is greater than 6.643. Do I round this value up or down? Good question. We always round up. The reason being as to why we don't round down is because, well, if I were to say that the minimum number of trials is just 6, then that means the probability won't quite be 0.99. It would be less than 0.99. And we want more than 0.99, right? So we have to round this up. So our minimum number of games, minimum number of times the coin need to be tossed is going to be n equals to 7. So 7 times is the minimum. So that's how you tackle these sort of questions. Now, there is another way of doing, finding this n value directly using your CAS, so I'm going to do it now. So what you do is press menu 5D, and cumulative probability is going to be 0.01. So 1 minus 0.99, 0.01. Probability of success, that's the probability of getting a head on unbiased fair coin, and number of successes is going to be 0 because we are finding probability that x is equal to 0. So 0, and then press enter, and there you go, you get your answer straight away. Okay, so let's move on to question 2 now. Now keep in mind that the CAS trick that I showed you is only going to work if it's going to be at least once. If it's going to say at least twice, which I'm going to cover in the next question, it won't work. And that's why I went through the entire method first before I give you this easy way out. I want you to appreciate the CAS as well as understand the method that we use to calculate this by hand, in case if this is an exam 1 question. So, Abdul's friend was gambling and the probability of him winning the game was 0.4. Find the minimum number of times his friend have to play the game such that probability of him winning at least twice is 0.95. Is more than, actually. I mistyped the question, so more than 0.95. Again, what's our first step? Come on, by now, if you don't say define the random variable, what the hell are you doing, eh? So, let x be the number of times he won. So let's write the syntax. X is binom. We don't know the number of trials, so n, and the probability of success was 0.4. So that part is done. Good. Now, what we have to evaluate is the value of n, which is number of trials, such that probability of him winning at least twice is going to be more than 0.95. Now, probability of winning at least, twice is same as writing 1 minus probability of x equals to 0 plus probability of x equals to 1. Right. So, all we are technically doing is finding this over here, and that would mean that probability of x equals to 0 plus probability of x is equals to 1 is just going to be less than 0.05. Again, I just moved this to the other side, moved this one to the other side and multiplied both sides by negative so that I can remove the negative, and that's why my sign has changed. And so let's calculate probability that x is equals to 0 is going to be n0 times 0.4 to the power of 0 times 0.6 to the power of n. So that's going to be 1 times 1 times 0.6 to the power of n, which is just going to be 0.6 to the power of n. Okay. Now let's calculate probability that x is equals to 1. Maybe I should do it on the other side. So probability that x is equals to 1, and that is going to be n1 times 0.4 to the power of 1 times 0.6 to the power of n minus 1. So that is going to be n times 0.4. Again, you can evaluate this using CAS because this is a tech active question, so it's fine. Times 0.6 to the power of n minus 1. And now we just simply add them together, so 0.6 to the power of n plus 0.4n plus 0.6 to the power of n minus 1 has to be less than 0.05. And if you evaluate this on CAS, I get two answers. So I get two answers. So first one being n is equals to negative 1.465 and n is going to be 9.821. Now of course n cannot be negative because n is the number of trials, and number of trials, you cannot have negative number of trials, so you must say that n has to be greater than 0. So our answer is going to be n equals to 9.821 approximately, which is going to be what? Do we round up or down? Up. Good. So 10 games. Alright, so this is going to be your answer, and this is how you tackle these sort of questions. Now, if you were to do this on CAS with the method I showed you previously, it will not work. I'll just tell you that. It will just not work, okay? So you need to know and understand this method in case if they ask you to do it by hand in your SAC or in exam 1 or whatever. So please try and understand the method as well as appreciate the CAS technique that I just showed you. Alright, so for this question I may have messed up. Now what I mean by messing up is not my method part. My method part is perfectly fine, so please learn from the method. But what I mean by messing up is that when I was recording myself doing this question, right, when I put in the final equation to solve for the values of n, I somehow got the values of n which are already on your screen right now, so negative 1.465 and 9.821. But when I was recording myself finding the values of n on my CAS calculator, I apparently found out that, well, there are no real solutions to this equation. I'm not sure how that happened. It's pretty weird. I'm still confused myself, but so my answers are incorrect for this question, unfortunately, and I do apologize for that. But please learn from the method. My method is 100% correct, and solutions are incorrect, which I again do apologize for that. Okay, let's move on. Mean, variance, and standard deviation. So pretty similar concept to what we did in discrete probability, except mean, variance, and standard deviation are a lot less tedious to calculate. We just apply formula. So mean, or also called as expected value. So in the question, if they say expected value, it's also going to be mean. So don't get confused. So EX equals to number of trials times probability of success. Variance has this formula, and standard deviation, well, it's still the same as discrete probability, square root of variance, so it's going to have this formula over here. Alright, so using this formula, let's practice question number 1. So Jack got 10 tries to play, and every time he wins, he gets $4. The probability of him winning is 0.3. If X is a random variable that represents the amount of money he makes, then find mean value of the amount of money that he makes. So EX is going to be number of trials times probability of success. So that will be 10 times 0.3, which would be $3. So his rough winning is going to be like $3, and that's quite understandable because, well, the probability of him winning is quite low. So yeah, and let's move on to variance. Of course, do not forget to write the units. If X is a random variable representing something, say time or money, you must include the units when you calculate mean, variance, and standard deviation. Okay. Variance is calculated by using n times p, whole thing times by 1 minus p. So sub in the numbers, 3 times 1 minus 0.3, and that will give you $2 2.1. Now, variance will always have a unit that is squared. The partial reason for that is in discrete probability, if you remember, it's going to be x squared minus the whole mean square. So as you can see, x squared in this case is going to be $2 minus the whole mean squared, which is also going to be $2. So $2 minus $2, the units are going to be the same. So our answer is also going to be in $2. So that's the whole reason behind why variance has its square unit. And this will be the same for, discrete probability. If you're asked to calculate variance and the random discrete variable represents something and has a unit, for variance please write the units to the power of 2. Okay? Alright. So standard deviation, pretty simple. That is just going to be square root of variance, which is going to be $1.45. So again, the units change here because variance has a unit of $2, and if you square root that, it's just going to be $. So that's how you calculate unit. Alright, I hope that made sense. Pretty simple question so far. And let's move on to this question now. So Peter is playing a game where his chances of winning is 0.2, surprisingly pretty low. Whenever he wins, he gets $2. If the expected amount, so expected amount should click a bell now, so ring a bell now, that it's, referring to mean amount that he won, and it was $21. Find the number of tries Peter took to achieve the winning. So E of X is going to be n times p. We know that n times p, which is probability, is going to be 0.2, is equals to 21, and so that means that n is just going to be 21 divided by 0.2, which is going to be 105 trials. So to get expected value, winnings of $21, he needs to, theoretically play this game 105 times. So yeah, if don't gamble. That's what probability teaches you. Just don't gamble. Okay. So question 3. Given that the expected value of a random binomial variable is 8.4 and the variance is 5.31, find the values of n and p. So, well, E of X, so the mean is just going to be n times p, and variance is going to be n times p times 1 minus probability, which is this is going to be 8.4 and this is going to be 5.31. So n times p, as you can see, is going to be 8.4. I can simply substitute that here. So 8.4 times 1 minus p, which is going to be 5.31. Now you can solve this on CAS and it will give you 0.368. Alright, so now we can just simply find the mean because we know the probability of success. So n times 0.368. Oh yeah, one more thing. Again, please do not use the rounded value to calculate your answers, especially in probability and as well as any other, question, any other concept or topic they're testing you on, try to use the exact value, the exact answer that you got from CAS. If you round up or down, even by a bit, the answer may vary and you can get it wrong. There are high chances that you can get it wrong. So always, always, always use the exact whole answer that CAS give you. And also, if they ask you on paper, write it to 3 decimal places, yeah, just write it to 3 decimal places. Don't write like 15, 20 decimals. So that's why you can see I only written 3 decimal places here, because yeah, I don't want to write, a full page of decimals. So, but in calculator, you must input the full, 15 decimal places if there are 15. So yeah, just getting that across, equals to 8.4. So n is going to be 8.4 divided by 0.368, and that will give you 22.835. Again, this is going to be 23 trials. Okay, I hope that made sense. Okay, so final exam style question. So this is our last question. Like I always have one of these at the very end to summarize everything that we learned. Cool. So Ramesh is playing arcade games, and X is a random binomial variable which represents the number of tickets he has won. The expected value of tickets won at arcade is 2000 tickets a day, and the variance is 900. Cool. Find the number of trials and probability of success. Well, again, same thing. EX is going to be N times P, and variance is going to be NP times 1 minus P, which is going to be 900, and this is going to be 2000. So I can substitute that in here. So to find the probabilities of 2000 times 1 minus P is going to be 900, and this, when evaluated on CAS, will give us probability equals to 0.55. And now using that, I can calculate the mean easily. So EX equals to N times 0.55, which is equals to 2000. So N is roughly going to be 3636.36, which is going to be 3637 trials. We always round up. Okay, now hence or otherwise find the standard deviation. Well, standard deviation, again, just square root of variance. So standard deviation is just going to be square root of variance. The variance is 900, so square root of 900, which is going to be 30. Do I move on? No. What am I forgetting? The units, tickets. Do not forget to write the units, because that will take away your 1 mark. So do not forget to write the units. We do not want to lose a mark over here. Okay. Find the probability that Ramesh is either 2 standard deviations above or below the expected value of tickets won at the arcade. Now, how do I tackle this question? It sounds pretty confusing by the wording, but if I were to draw a diagram, let's just assume that this is a bell curve question. So if I were to draw a diagram, this is our mean, which is 2000, because below or above the expected value, which is the mean, so 2000. This is going to be 1 standard deviation away, 2 standard deviation away. Same here, -1, -2. So what we are technically finding is the probability that he's either in this region over here or this region over here. How do I do that? Well, there is an easier way we can do this. So the first things first, we have to write the syntax that X is binomial of 3637, 0.55. Again, number of trials and probability of success. So what we are finding is probability that he is either 2 standard deviation above the mean, so mean plus 2 standard deviation, or we are finding probability that he is below 2 standard deviation of mean, so mean and 2 standard deviation below that. What we can do is we can simply evaluate this area over here and then take that away from 1. Why am I doing that? Why can't I just use calculator to find this? Well, to calculate this portion over here, there's going to be absolutely no problem, because the lowest can just be 0 in binomial. But the problem comes over here, because this bell curve keeps going on and on and on and on to infinity. And I cannot type infinity when I'm calculating binomial stuff, so I cannot use that method over here. Well, I can, use approximation. I can, make the number pretty big, but we want an exact answer. We don't want to get even a single decimal place wrong. So there's an easier way to do this, and that's why I said we first calculate this area over here and take that away from 1, because that would ultimately give us the same result, right? So how do we do that? Well, this is the same as me writing one takeaway probability that X, which is the number of tickets he has won, is between mean minus 2 standard deviation and mean plus 2 standard deviation. Okay, so let's calculate this probability over here. So 1 minus probability of 1940 less than or equals to X less than or equals to 2060. And let's do that on CAS now. Alright, so to do this question again, menu 55B, number of trials this time is 36, 37, probability of success is going to be 0.55, lower bound is going to be 1940, and upper bound is going to be 2060. Press enter, and this is your solution. Now let's take that away from 1, so 1 minus this whole thing over here, and there you go. So we saw that it's going to be 1 minus 0.9563, and that is going to give us 0.0437. Okay, so that's it. That's the answer for this question over here. Okay, Ramesh's friend Atif like this game at arcade where the chances of winning jackpot are only 8%. Find the minimum number of times Atif must play this game to ensure that the probability of him winning at least once is more than 0.95. Now again, you can use calculator for this, but I'm still going to show you how to work it by hand for those of you who need a little bit of more practice. So what is our first step? By this time, if you didn't say define our random variable, I don't know what you're doing, so you better say define the bloody random variable, okay? Good. Now, can I use X as a random variable in this question as well? No, because this is a complete different scenario. What does X represent? Well, X represents the number of tickets Ramesh has won. And now we are talking about Atif winning a jackpot. So there are completely different scenarios. So what does that mean? We have to define a new random variable. So let's do that. Let Y be the number of times Atif won. So Y is binomial. N, because we don't know the value of N, and chances of him winning is 0.08. Cool. So now what we are finding, again, probability that he wins at least once is greater than 0.95, and that again is going to be probability of Y greater than or equals to 1 is going to be the same as writing 1 minus probability that Y is equals to 0. So 1 minus probability of Y equals to 0 has to be greater than 0.95, and that would mean that probability of Y equals to 0 has to be less than 0.05. Again, I just did simple algebra over here, moved one to the other side and multiplied the whole thing by negative, and that's why my sign has flipped. Okay, so let's calculate probability that Y equals to 0, which is going to be N 0 times 0.08 to the power of 0 times 0.92 to the power of N is less than 0.05. So this is just going to be 1 times 0.92 to the power of N is less than 0.05. So 0.92 to the power of N, this is less than 0.05. So N is going to be greater than log base 0.92, 0.05. Now again, why did I change my sign? Because look over here, this is 0.05, which falls under the range of 0 and 1, where the log is negative. So the sign flips. Okay? Alright, very good. Now, this is the answer that you would, leave if this was an exam 1 question, unless they have specified that this is going to be equals to something. But yeah, this is the exact answer. But of course, we are looking for a decimal place, or we are looking for a number, not a logarithm. So let's do that. Let's evaluate this on CAS. CAS gave us that N is greater than 35.928. Now, again, do we round up or do we round down? Good, we round up. So N is going to be greater than or equals to 36. So the minimum number of times Atif needs to play the game is going to be 36 times. Alright, and that's all for binomial distribution. I really hope that you learned a lot of things from this, and I have covered majority of the different set of questions that we can ask you in this sector. So thank you all for watching, and I will soon see you in the next probability video. Bye bye.